All right, so we are now recording. Once again, we are covering chapter 3 this week, and which is all about alkanes. And like I said before, a huge chunk of that will be spent on nomenclature and what a methyl means, what a substituent means, what's the difference between iso, sec, and terbutyl. Hopefully you guys have covered that in lecture already. Well, I understand it's a Tuesday, so maybe you still have to cover it on Thursday. So before I get into it, does anyone have any questions from the previous session or anything from last week that you guys want to quickly go over before I get into this week's topics? So this includes anything regarding hybridization, resonance, functional groups, anything like that, bonding. Okay, so if no one has any questions, we'll get started. Let me use the whiteboard. Okay, so nomenclature is not what you think it is compared to Gen Chem. Gen Chem, the nomenclature that you're used to is the compounds. So we're not naming compounds. We're naming actual structures now, physical molecules. And there is a method to it. There's a process, and there's different rules that you have to follow. So we'll talk all about that. Okay. So first thing I want to start with is what methyl means. So if you see a CH3, it's going to be considered a methyl. Okay. Does anyone know, and please let me know in the chat, what this means? CH3, CH2 means. Any ideas? That's correct, yeah, it's an ethyl. So, then, so if we just keep adding carbons to it, CH3, CH2, and another CH2, it's going to turn into propyl. And we only have to go up till the 4th carbon, because that's all we have to really deal with in OChem 1 or OChem 2. So CH3, CH2, another CH2, and another CH2 equals butyl. So that is the Lewis structure form, and obviously that is what it looks like in the word. But now I'll show you what it actually looks like. So methyl is kind of hard to show because it's kind of just a single carbon. But I'll show a more clear version when I talk about all of these and what they look like. Ethyl is going to look like this. Imagine this is the R group. Maybe that might make it easier. So R group, we imagine that as the parent chain. R just means that it's any number of hydrocarbons. And then propyl is 3 carbons, so 1, 2, 3. And then butyl is going to be 1, 2, 3, 4. Oh, don't know how that happened. Let me see if I can fix that. Ooh, okay. I don't think it's letting me erase it, but it's fine. Okay. All right, there we go. Yeah, so butyl, again, it's 1, 2, 3, 4 carbons, okay? And I really want you guys to get in the practice of numbering all of your carbons, okay? Regardless of what you do, whether it's nomenclature, hybridization, resonance, just get in the habit of numbering. Oh, sorry. So it's not 1, 2, 3. It's going to be 1, 2. So again, 1, 2, 3. I know that's kind of hard to see. 1, 2, 3, 4. Okay. Yeah. Did you have a? Okay. I guess you lowered it. Okay. If anyone doesn't know what I'm talking about, please feel free to ask a question in the chat or raise your hand at any point. Okay. So we're going to continue with the different substituents you might see. So you might also see halogens. R just means yes. Okay. So someone asked, can you explain why the point at R is not considered a carbon? It is R does contain R can be anything that we assign it to. R is just the rest of the molecule. Okay. And in this particular exercise, R basically stands for the parent chain, and these are all your substituents branching out from your parent chain. Okay, everything that I'm writing here, we're going over substituents. Okay, if anyone doesn't know what a substituent is, let me know. But just as a refresher, okay, yeah. Just as a refresher, a substituent is any other atoms on our model that is not part of the parent chain. Okay, so if we have branches and things coming out of our parent chain, which is the longest carbon chain, that is considered to be a substituent. And I'll visually show you guys what I mean. Okay, any other questions? All right. So like I said, we have okay, someone asked, so are there any substituents in these examples? So all of these are actually substituents. Everything that I numbered are, they're all substituents. Methyl, ethyl, these are all substituents. Okay, and specifically, these are called alkyl groups. Okay, alkyl just means carbon to carbon groups, and then we have another category of substituents called halogens, which you guys should be very familiar with from Gen Chem. So these are your fluorine, chlorine, bromine, and iodine. Okay. And when you name fluorine, chlorine, bromine, and iodine, you don't say the full name. You have to say for fluorine, it's going to be fluoro. Chlorine is going to be chloro. Bromine is going to be bromo. And lastly, iodine is iodo. Okay? So once again, you'll be using these nomenclature or names in your full structure name. Okay? So you have alkyl groups, you have halogens, and then you could also potentially see. Oh, I'm sorry. Maybe, okay. Maybe try relog. Okay. Try relogging. Can everyone else hear me, or? Okay, awesome. Yeah. Okay. All right. So anyone that's just joining in or didn't get the introduction, we're going over nomenclature. Specifically, we're going over, or as a whole, we're going over chapter 3, which is alkanes, and I'll cover everything about alkanes. And if you guys ever want me to talk about anything in your chapter or that this week that you're going over or anything from previous weeks, let me know, and I'll try to clarify anything that if you guys have any questions. And once again, this is being recorded. Your names are not showing. Obviously, your audio and mic is also muted. Yes, I can definitely go resonance. I was also going to say that recording of last week's is already posted on YouTube. If you go to our channel, Peer Tutoring at UT Dallas, I did go over what's there, but I can go over again this week as well because it's a very important aspect. Someone asked, when will this be posted on YouTube? I can't remember the answer to that, or at least I don't think I know the answer to that. I think the recording that you see on e-learning, it will be posted in two places, both on YouTube and on e-learning. The recording on e-learning should be immediate, and the one on YouTube should probably be within 24 hours, ideally. Okay, so resonance as well as someone asked, can we do inductive effects and hybridization of carbons? Okay. Yes, we can do that. Let me quickly go over nomenclature, and then we can backtrack to any clarifications from last week. All right, does that sound good? All right, so yeah, in case you have to leave for class or arrive later, that's perfectly fine. Obviously, there's a recording of it, so feel free. Don't feel obligated if you have prior obligations, but I'm here to as long as until 3:15. All right, so another category is, it's very short, it's just alcohols, and you'll see it as OH, and then how it's denoted is going to be it's going to have a suffix of OL. So this is why I'm sure you guys heard of the term methanol, ethanol, propanol, and butanol. Basically, we added the OL. Yes, alcohol is a substituent, okay? Everything I've done, everything in blue is a substituent, okay? So this suffix and suffix ending. Okay? And also, these aren't technically, maybe I'll put a star here. Okay, so next I'm going to talk about iso, means isolated. Sec means secondary. And lastly, tert, or T, equals tertiary. And this only applies to propyl and butyl. Iso only applies to propyl, and butyl applies to all three. So maybe let me do this. So all of these, it applies to butyl, and then only this only applies to propyl. And once again, I apologize for the messy handwriting. It's not as easy as a whiteboard. And we'll talk about what all three of those look like. And I'm not sure if you guys have heard or learned about iso means isolated, sec means secondary, tert means tertiary, but that's what they mean. Hopefully that helps clarify some things. Okay, so what I'm going to do is I'm going to draw a large parent chain, and I'm going to go through each of the substituents and what they actually look like in your in your examples. Okay? So if anyone is still copying down or taking a screenshot or whatever, let me know now, because I'm going to erase the screen. Okay? I'm going to erase the screen. All right. So I'm going to draw a giant carbon chain. In class, obviously, it's never going to be this long, so don't worry. This is just because of the example, okay? So in red, I'm going to draw what you should see. I'm going to go through all of them, and I want you guys to take a minute as I'm going through these to individually think about what it could be and what's the name of it. So that's one. Okay. All right, so that should be, actually, there's a few more. All right, I think that gives us enough examples. All right, so I'm gonna quickly go over everything. Once again, the black is your parent chain. Those carbons are already called for. So the only other carbons we have are like I said, it's good practice to number these. So I'm gonna go through all of these to number them. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. This one is also 4. I'm numbering the carbons of each individual substituent chain, okay? So you don't want to get this mixed with parent chain, which in this case, it's the black. Okay, all right, perfect. So now let's actually go through these, okay? Okay, so this top one is we have a single carbon, so that's going to be a methyl. Down here, we have 2 carbons, which is ethyl, 3 carbons, which is propyl. So these are 2 individual methyls. So I put 1, 1 to show that this substituent has 1 carbon here, and this substituent has 1 carbon here. This carbon has 2 different or 2 separate substituents. They're the same because they only have 1 carbon, but they have 2 separate substituents. And I'll talk about, I put this to explain that you could have 2 substituents on 1 carbon. So we don't number these carbons because think of them as already claimed, quote unquote. So these carbons have already been numbered when we went through and found the longest chain. Okay, so imagine this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay, and so on. Sorry about that. Yeah, so those numbers that we already found the longest chain, in this case, let's assume it's 13, we don't have to recount those carbons. Those carbons are already claimed for, forget about them. Now, after you found your parent chain, I always recommend circling everything. In this case, we made everything red, so it's already obvious. But I want you to circle your substituents because it would be much more obvious. So you can. It also helps you prevent, missing any substituents when you name it. Okay, and we'll go over examples before this review ends. Okay. All right. Those are great questions. Okay. So propyl, and then down here is actually called isopropyl. Okay. And once again, isopropyl means it's isolated, and specifically, it's isolated at the very end. Okay, at the final two carbons, it's going to split, kind of like a fork. Well, like a fork in the road, but it's going to split in two directions. Okay, this one is called N-butyl, and I should probably change my propyl also, because they're both propyls, but if it says N, if you ever see N, that just means it's in a straight line. Okay. N is, I think N stands for number, like the substituent. But regardless, don't worry about it. You never have to say N. You don't have to say N dash propyl in your answer. Obviously everything's virtual, so I'm not even sure if you have to type. Maybe it's probably all multiple choice, but yes. So if it says N, it's just a straight chain. If it says iso, that means it's isolated at the very last two carbons. So propyl has 3 carbons, so carbon 3 and 2 are going to be split into 2. Butyl has 4 carbons, so carbons 4 and 3 are going to be split into 2, or like different directions rather. So that gives you a hint on what this one is. It's called isobutyl. Okay. And then this one is called sec-butyl. Again, sec means secondary. And down below we have tert or T-butyl. You could see both ways. Don't be alarmed if you see one or the other. And then we have 2 halogens, chlorine and bromine. Explain what that was previously. Chlorine is chloro, bromine is bromo. Now, when we get to right here, I have 2 individual substituents. Okay, whether they're the same or different, that's besides the point. And most likely it will usually be the same, but you can have different substituents. So does anyone know what 2 of the same substituents we have? And these are, I guess, your options. Yeah. And yeah, you gave me the extra answer too. Because we have 2 methyls, we have to denote that as dimethyl. Okay, di meaning 2. Okay, let's say for instance we have 3 methyls, which can happen if we have like let's say we have in this example it doesn't really work because you still have the longest chain. So don't get confused, because when you number this 1, 2, 3, 4, you no longer have 3 methyls. You only have 2 methyls, because the third one is actually contributing in your parent chain. Okay, so that could kind of trip you up. So you always want to find the longest carbon chain that you can connect. Okay, and yeah, so this is di, but let's say there was 3 methyls. It'd be tri, and those all 3 methyls does not have to be on the same structure. Okay, let's say on this example that we have here, I have another methyl there. Okay, so I have 2 methyls here and 1 methyl there. They would all undergo the same name. They would still be trimethyl. Okay, so however many same substituents we have, that's how many on the whole structure. That's how many di, tri, or tetra that you will have. Okay, and then finishing up with our example, last but not least, alcohol. It ends with a OL sound, okay, or suffix. Does anyone have any questions on all of these substituents? Okay. Let me know if you still don't understand it after the example. Okay. Someone asked, can you please explain what sec and tert are? Okay. So I mentioned on the previous page where sec means secondary. So if you see here, at my first carbon, the remaining carbons are split into 2 different directions at the very beginning. Okay, so sec separates at the beginning, and iso separates at the very end. Okay, so sec and iso are very similar in that they split, and iso just means it's tertiary. That means this carbon, this middle carbon, is a tertiary carbon, and you'll understand what tertiary means a lot more in exam 2, or unit 2 rather, like primary, secondary, tertiary. So don't worry too much about tertiary. Just understand tertiary kind of looks like a tree or a T, and also I'll write this in the text box here just in case if you guys want to take a picture. Tertiary means tertiary. Okay. So please use this as a reference point while you're learning about nomenclature. I'll get into an example, and hopefully after that you guys will understand substituents. Okay. Remember, these are just for nomenclature, just to name your structure. Okay. OCHEM is a lot more. It deals with reactions. That's the bulk of OCHEM, reactions. So this is still kind of the beginning. Okay. Does anyone have any objections before I clear the page? Because if I clear the page, we can't go back. So make sure you have it down if you want to copy it or take notes. Okay. If everyone is good, I'm going to clear the page. All right. So I am going to come up with an example. So bear with me, or give me one moment. Okay, this might have been a little bit harder than you guys can handle right now, but that's fine, okay, because I'll walk you through it, okay? And if you're able to do this, you should get a much better understanding on how to do any nomenclature, or a lot of nomenclatures, okay? So I'm gonna walk you guys through it just because it's the very first one, and then maybe I'll put up another example while you guys take a few moments, okay? So the very first step, and I'll type this down, first step is to find longest chain, okay? That's always what you want to do, okay? Find the longest chain. Let me correct that. In the right order, okay? What I mean by that is sometimes you might find the longest chain, but depending on the numbers of your substituents, your chain could be either reading left to right or right to left, okay? Basically, it could be in reverse direction, okay? And I'll explain what I mean. So let's go ahead and do number 1 first, and we'll continue, okay? So the normal reaction that a lot of students do is just go this way. So 1, 2, 3, 4, 5, 6, 7. And that is not always the case because you have different substituents, or they look like substituents, but they also can be part of the chain. Okay, so for example, if I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, maybe 10 is a little bit too big. We'll stick with that. Okay, so let me erase that and see how that changes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, sorry guys, let me fix something. I'm trying to keep it so that it's only 8. Okay, yeah, that's perfect. All right, so I already kind of gave you the answer saying that it's 8. So I'm going to start numbering. So I'm going to start numbering from how you normally would if you don't kind of analyze this. So at first glance, you would think 1, 2, 3, 4, 5. And then instead of going to the right, you have to go down below, okay, to get a higher chain. 6, 7, 8, okay? However, we can also go from 1, 2, 3, 4, 5, 6, 7, 8. Regardless of which direction we go, we still get the same number because it's dealing with the same carbons, okay? Before we move on, or before we decide which is the right order, I am going to circle all of my substituents. I suggest you do the same. So I have a substituent there. You do. We have to decide which order to go, and I'll explain how you can go. Sorry. Okay. Let me erase this chlorine because it doesn't really fit. Sorry about erasing everything. Okay, so that means this is another substituent. Okay, and yeah, someone asked, so we don't have to go a specific way, left to right. So you don't, yeah, sorry, you don't have to. It doesn't always have to be left to right. It could be right to left. It could be top to bottom, bottom to top. It could be any direction, as long as you find your longest carbon to carbon to carbon chain, okay? All right, so Sorry for erasing a lot of things. I'm kind of making up the problem as I go. So I circled every carbon or substituent that I didn't number in purple. Okay, so the ones in purple, these are considered to be my substituent. Okay, so I have one right there, one right there, and then this big one right here. Someone asks, so you just numbered the parent chain, the carbons on the parent chain? Yes. All I've done so far in the red and green is numbered my parent chain. Okay, and this with this given structure that I made up, this is the longest carbon to carbon that I found, which is 8 carbons. But like I said, if you go one direction, which is the red numbers, you can also go the reverse direction, which is the green numbers. So now what our job is to find out which way is correct. And we can do so. Sorry, before I get ahead of myself, let me update kind of like the sequence of events. So find the longest chain in the right order, number them, and circle your substituents, and then figure out which way has the smallest number on your sub. That kind of went off the page. Let me bring this up. Okay. All right, so someone asked, how can you tell that the whole bottom part isn't a substituent? That's actually a really good question. Okay, so this whole bottom part isn't a substituent because these are still carbons. You can still go down this way. So when we counted in the red direction, when we got to 5, let's say I'll erase this later, but let's say straight, we get 6, 7, and if we decide to go top, we also get 6, 7. Okay, so we only get 7 carbons going this way. Okay, but if we go down below, we can get more carbons. We can get a higher parent chain number, which is number 8. Okay, just because it's sticking out up and down does not mean it's guaranteed a substituent. Things to the side can also be a substituent. Okay, and you'll learn to recognize different ways as you do more problems. So someone says, so the reason the bottom isn't a substituent is because we consider it part of our parent chain. Yes, that's exactly what I'm trying to say. Substituents are only things that we cannot include in our parent chain, okay? But because we can include the rest of these carbons in our parent chain, anything that we didn't number in red or green is considered to be our parent substituents, in purple, okay? And I've numbered the ones in green, orange, just to show you that if you go to the right, it won't work. So I'm going to erase those numbers so we don't get confused. Someone asked, so the parent chain is the way that has the most carbons? Yes. But like I said, we have to figure out if we're going the red direction or the green direction. Okay. So in order to do so, so we're on step 4. We have to figure out the substituents, so the purple ones, what number they're located on. Okay. So if I do red, or let me just go in order. So on carbon 4, sorry, okay. Before we do any of that, let's name our substituents. And that will make life easier for you guys. Okay. So can anyone tell me what substituent we have right here on carbon 4? Methyl. Okay. What about this one right here? Someone said butyl. Okay. isobutyl. Okay. So I want you guys, so how you can figure out how many, like what it is, you can, yeah, so the correct answer is isopropyl. Some people got it, some people didn't, so I'll clarify that. So once you covered your parent chain, you then want to renumber all of your substituents to figure out what kind of alkyl group it is. Okay, obviously if it's a halogen or alcohol, you don't have to renumber. We're only numbering carbons. But alkyl, which means any carbon to carbon chain, then you do have to renumber. Okay, and I'm going to renumber in purple. So here I only have one carbon, one carbon, one carbon. But here I have 1, 2, 3. And if you guys remember from the very beginning, 3 carbons means propyl. And then in propyl, there are 2 different ways. It's either in a straight chain or it's isolated at the very end. Okay? And yeah, a lot of people said iso, so they got that part right. But instead of butyl, it's going to be propyl. Okay. Is anyone still confused why this is isopropyl and not isobutyl? If you are, let me know. Okay, looks like we're all on the same page. And I'm gonna write this methyl, and then obviously you guys know that these are methyls as well because I numbered it. And then this is isopropyl. I'll just abbreviate it as P. Okay, so now that we have that, I want to compare the red and the green. Okay, so typically we have to look at the numbers. So for the red, we have 4, 5, and then 6, 6. Yeah, definitely, I can explain why. So someone's still confused why it's propyl, not butyl. It is propyl simply because it has 3 carbons. Butyl has 4 carbons. And there's 3 carbons not including the parent chain. Okay, 3 carbons in a row. Okay. And hopefully the iso part makes sense. Okay, all right, perfect. So yes, okay. So I'm gonna write out all of our substituents. And before I do that, remember, like I said, if I have the same substituent, I'm gonna have them all under the same thing. So I have 1 methyl here, 2 methyl, 3 methyl. Let me finish this, and I'll explain why someone asked why it's dimethyl, and then that's a very good question, and I could see why you would think that. But let me go ahead and finish this. Okay. So when we have, oh, that's not what I wanted to do. Okay. So when we have multiple substituents of the same substituent, so methyl groups, right? We denote this as 4, 6, 6 dash trimethyl. Tri because we have 3, and methyl because that's the substituent we have. All right, there we go. So that is what we have for all of our methyls. And then next, for the isopropyl, it's on the parent chain carbon 5, so 5 dash iso propyl. Okay. So we are comparing that to the ones in green. So if we look at the ones in green, we have 3, 3, 5 dash trimethyl. And then our isopropyl is on 4 dash isopropyl. All right. Does this part make makes sense. And I don't think we need to capitalize any of these, so I'm just gonna change that back. Okay. So is anyone confused how I got these numbers and the substituent names? For the person who asked me why it's not dimethyl, I'll explain that real quick. Okay. So in the meantime, I'll explain it. The rest of you try to see which one we prefer. Okay. So it is not dimethyl, and I can see why you would think that. Okay, yeah, I repeated 6 twice because we have we have 2 substituents on both of these methyl we have 2 methyl groups on 6. Okay, so there's a methyl here, there's a methyl on here as well. Okay, that's why I repeated 3 also. Okay, and here it's not dimethyl because this middle carbon is also is part of the whole substituent. Okay, it would be dimethyl if this middle carbon was part of our parent chain. Then this carbon 2 would have a methyl right here and a methyl right there. But because this carbon is also part of the substituent, as a whole, we have 3 substituents. That's why it's isopropyl. Does that clarify things? If it doesn't, if it's not, okay, yeah, that's fine. If it's not clicking right away, don't worry. This is all very new, I understand. But as you get more into it, it will make more sense. I know we're kind of taking our time, kind of going through all of nomenclature, but trust me, I explain it slow because I want you guys to fully understand it and grasp it the first time you learn it and not have to circle back and get confused. Okay, now we're going to talk about red versus green. Obviously, which one has the smallest numbers, red or green? Yes. So because green has the lower numbers, we are actually going to go this way in the reverse direction. So I'm going to, actually I'm not going to delete any of that. So we're going to choose this because it has the smallest numbers. Okay? So now that we selected our side, we already have all of this organized, and we have our parent chain, which is 8 carbons. We can fully write the name of this structure. Okay? And I'm going to type that. Does anyone want to take a guess on like the order and how it's fully written? Please type it in the chat if you want to. I'll give you guys about 15 seconds. Yeah, the nomenclature, not necessarily the empirical formula. So you guys someone said 4-isopropyl, 3,3,5 trimethyl octane. Okay, yeah, that's perfect. Except obviously you want your dashes in between. Okay, so I'm going to type out the right answer. And the reason why isopropyl comes before trimethyl is because for iso, the I counts in alphabet, but when you do sec and tert, the S and P don't count. Okay, what I mean by that is when we say sec butyl or tert butyl, you look at the letter B instead of the letter S or T. But for, let's say, instance, isopropyl or isobutyl, you compare the letter I to the rest of the substituents, okay? So in this example, we're comparing M versus I, and clearly I comes before M, so that's why iso gets priority or when naming it. So it's going to be 4 dash isopropyl dash. So between every substituent you place a dash, 3 comma 3 comma 5 dash trimethyl. So you don't have to place a dash between the like di, tri, tetra. And between the final substituent and the parent chain, there is no dash as well. Okay, so it ends up being a one word. Okay, so this is the final name of the structure. Let me know if anyone has any questions regarding any aspect of that name or anything that we've done. Okay, someone asked, do you have to include octane or does that not matter? You most definitely do have to include octane because that is your parent chain. You're naming not only your substituents, but your whole parent chain. If you don't include your parent chain, all you're naming is the purple substituents. Okay, think of the parent chain as like kind of like your backbone. So the parent chain will always go at the very end. If there were 7 carbons, it would be a different name, right? Instead of octane, yes, it would be heptane. 6 is hexane. 5 is 5 is pentane. 4 is butane. 3 is propane. 3 or 2 is ethane. So methane, ethane, propane, butane, and then after 4 it's pentane, hexane, heptane, and then octane. And then 9, I believe it's nonane, and 10 is decane, but hopefully they won't make it that big. So someone else asked, how did you know the parent chain is octane? So I know the parent chain should be called octane because when I numbered it and I was trying to find the longest chain, I got 8 carbons. In any direction I go, I always end up with 8 being the very highest carbon to carbon. So that's why I got 8, and 8 equals octane. Okay? Does anyone have any other questions? Did this help? Did this clarify things? Or is anyone still a little bit confused? Awesome. All right. So we're kind of running out of time. We have 15 minutes. So someone asked if we have to know all the way up till 10. Like I said, from what I've seen, they usually go up to 8, but I wouldn't be like, I think it's fair game to say it could go till 9 or 10. But most likely you can just go to 8. But once again, if it does go to 9, 10, 9 is nonane or nonane, or 10 is decane. All right. So, all right. Yes, I'm very glad it helped. Okay. So I think that's all I'm going to do for nomenclature. Okay, yeah, we can do one more example. We can do so this is my weekly review. The weekly review is every Tuesday from 2 to 3:15. Stay a couple minutes after if you guys have any questions and if you guys want to talk about something. But I normally tutor from 10 to 12:30 in peer tutoring in the chemistry folder, as well as Wednesdays 11 to 1:30. Okay. But peer tutoring's open 10 to 8 on most days. The schedule's put if you guys have any more information. Okay. And then someone asked if we can do one more example. Yes, we most definitely can. So I'm going to clear the page. Yeah, so Wednesdays 11 to 1:30, and then Tuesdays 10 to 12:30. Okay. And because it's beginning, there's not really many students. Chemistry kind of comes in waves, so don't try to be that person who only comes during the week of the exam, because it won't be as good of an experience for you and you won't get the most out of it. So I highly recommend coming every day, or at least make it a habit of coming maybe 2 times per week at the very least, so you guys can get a more rounded education. All right, so we can do a quick example. I'm going to clear the page. Okay, and then I'll put chloro here. Okay. So this is your structure, and in the interest of time, I will go ahead and walk it through. So we can go this way, 1, 2, 3, 4, 5, or we can go this way, 1, 2, 3, 4, 5. Okay, and it doesn't really make sense to go, to one of these or down below, because after 3, you only have either 4 here or 4 here. Because 5 is clearly better than 4, we can just go right to left or left to right. Now, like I said, there's 2 different ways. We have to pick the right way. And I also want you guys to circle everything that we didn't count for. Sorry, that should be 2 separate ones. So one right there, third one right there, and then we have a chlorine. Okay, and then let's also name our substituents. We have methyl here, methyl here, methyl here, and then this is chloro. It's a chlorine, but we have to pronounce it or spell it as chloro. Okay? All right, so now we have to decide, based on our substituent numbers, which way is better. And this is actually an easy example to do so, because 1, it's it's not too big, it's only 5 carbons, and 2, we have yes, so someone said, would 3 not be dimethyl? 3 is definitely dimethyl, so you got part correct. But what I was trying to say is, when you have chlorine compared to alkyl groups, chlorine takes priority. Okay, so you want chlorine to be on the smallest number compared to alkyl groups. Okay, and if there's kind of a hierarchy, so alcohols, then halogens, and then alkyl groups. Okay, once again, alkyl groups means methyl, ethyl, propyl, butyl. Okay, this is the suffix. Okay, if you ever forget what alkyl means, it has the YL ending. Okay, and this is kind of a very short list of what you currently deal with. You can certainly deal with a lot more when you get to like double bonds, triple bonds. I don't think they will put like other functional groups like a ketone, carboxylic acid in naming, but if they do, then we can talk about it. Yeah, 3 is dimethyl, just to clarify if people are still confused. Okay, but because chlorine is our halogen, it takes priority. We want chlorine to be on number 2 rather than number 4, which is why we're going to go from red, so that means left to right. Okay, so I am going to actually erase the green ones just so you guys can see and make it easier on you. Okay. Priority, priority as in it takes, we prefer to have chlorine on smaller numbers because it is, I believe it has to do with weights. Actually, no, it does not have to do with weight. The priority list is kind of predetermined, I think by IUPAC. And I'm sure if you Google like nomenclature priority list, you can find one. What I mean by priority, I just mean in terms of numbering our parent chain. That's why we went this way rather than the other way. So priority in numbering our carbons in our parent chain is different from when we actually name it. Okay, because when we name it, it's always going to be in alphabetical order. But when we number it, most likely it's like, I don't want to say heavier, because alcohols are not heavier than halogens, but use this to number. Like, for example, let's say carbon 5, actually, oh god, okay. Let's say carbon 5 had alcohol right here, then we would actually go right to left. Then this would be our number 1 because alcohols takes priority. Okay, and then you said, but we base it on alcohol, halogen, and alkyl. Yes, yeah, that's the order. Okay, so yeah, if there was an alcohol, then this would be our number 1. But because there's no alcohol and you're just comparing alkyl and halogens, we have to number it this way. Okay. All right. Let me erase the alcohol that we added. Okay. Yeah, I know when we mix in alcohols and halogens, it gets a little bit messy and priority kind of gets a little confusing. But hopefully, don't let that throw you off the entire process. Okay. So to name this, sorry, we have 2-chloro, and we also have 3,3,4 trimethyl. Okay, and parent chain equals pentane because 5 carbons. So to put it all together, you have to put it in alphabetical order. So chlorine, okay, C versus methyl, chloro versus methyl. So which one comes first? Yeah, C definitely does. So 2-chloro dash 3,3,4 dash trimethyl, and then between trimethyl and pentane there is no dash, so it should be like this. Okay. Any questions how we got this nomenclature for this structure? Okay, that one might have been a little bit trickier than the longer one just because we added the chloro, but hopefully you guys are able to understand it. Okay, any questions? Okay, let me scroll up to see what you guys had. Someone said inductive effects, hybridization. Okay, and then resonance. Okay. I feel like I have, if you go back to the first recording, either on eLearning or YouTube, you can find um, the weekly review on resonance. I think that should clarify things, as well as hybridization. I went over it pretty well, but I can't talk about inductive effect because I don't think we've talked about acid bases yet. Right, yeah, that's fine. But yes, please look at the recordings, even this session, even if you're here live. It's definitely good to go on your own pace and carefully understand it for the quiz or the exam. But definitely do come live, so you can ask questions. Don't just see the recordings and not come to the actual review. All right, so I'm going to clear the page. Someone else, they wanted to go over induction effects. And this is kind of getting into, I guess, next week's topic. Well, this is like acid bases. So there's a acronym / checklist that we use for ranking acids. It's called ARIO. Has anyone heard of this before? Okay. Can you tell me where you heard it? So A stands for atom. R stands for resonance. I stands for inductive. Okay, PLTO. Okay. So I stands for inductive effects. So have you guys covered acids and bases and how to rank acidity? O stands for orbital in lecture. Sorry. Okay, all right, perfect. Okay. So we only have like 2 minutes, so I'm just gonna quickly just introduce the topic, and then maybe in the beginning of the next weekly review next Tuesday, I can do a full fledged example. Okay. So ARIO is an acronym. It is it's like a checklist to help you go through your 5 given molecules, and then using this checklist, you'll be able to rank 1 through 5 which atom or which structure is the most acidic, second most acidic, and then so on until the least acidic structure. Okay. In atom, you are specifically looking at charge, or the size of the atom that contains the negative charge. Okay? You're not necessarily looking at the electronegativity of the atom. Okay? Um, Hey, can you guys hear me? Okay, awesome. Sorry, I think my audio cut out. And I know we're a little over time, but let me finish this in a minute and then we can go. So yeah, resonance is good. Inductive effect, it could mean either location or strength. I'll go over this extensively, and orbital just means, sp is better than sp2, which is better than sp3. Okay, and this is for a city. Okay, with basicity, it's a different set of rules. Okay. Yeah, so I'll just stop there. We'll go over it extensively next week. I think you guys are also starting to talk about stereochemistry, so I'll get into isomers right before your exam, which is coming up on September 23rd. Okay. So let me know if you guys have any questions. If not, we can end the session, and then I'll see you guys next week. Yeah, no problem. Thank you for coming.